Hello guys, today I'll be explaining the physics periodic quiz from 9.4 until 9.7. This is the course practice quiz, so let's start. The diagram below shows a segment of a roller coaster. The mass of the roller coaster train is 4.5 times 10 to the power of 3 kg. Take the g is equal to 10 meter per second squared. Okay. Drag and drop the answers to complete the sentences below. They need the work done by gravity as the train moves from position 1 to position 2. Whenever we're talking about gravity, if it's going down, then it is positive. If it's going up, then it is negative. This is only when we are talking about gravity. So for gravity, if it's going down, it's positive, and if it's going up, it is negative. So to find the work done by gravity, we know that the formula for work is force times distance. So W is equal to force times distance. Gravity exerts which force? What force is done by gravity? It is the force of weight. The force of weight is equal to the mass times the gravitational attraction. So very simply, you can you can substitute the force by mass times g. The distance, whenever we're talking about gravity, we will substitute it by h. H is always vertical. H is always the vertical distance. So now, the work done by gravity as the train moves, we got mgh for the gravity. So the rule for gravity is mgh. We also know it can be positive or negative. If it's positive, it will be going down. If it's negative, it will be going up. So let's see. They need moving from position 1 until position 2. Position 1 is here, position 2 is here. You notice that the arrow is going downwards. Since it's going downwards, we will be using the equation plus mgh. So let us substitute. We have the mass, which is 4.5 times 10 to the 3 kg, multiplied, again this is plus, multiplied by what? By the g, which is 10, and multiplied by the height in meters. Always pay attention, in physics the mass is in kilograms and the height is in meters. So the height in meters from position 1 until position 2 is 60 meters. So if you do it on your calculator, you are gonna get 2,700,000. I believe they want it in megajoules, so to change it from joules, this is your value in joules, to change it into megajoules, you are gonna divide by 10 to the power of 6. So if you divide by 10 to the power of 6, you are gonna get 2.7. So your answer for the first one is 2.7. For the second one, they need the work done by gravity as the train moves from position 2 to position 3. From position 2 to position 3, we are going upwards. So gravity, if we're going upwards, it's gonna become negative. So we're gonna use minus mgh. We have our mass, which is 4.5 times 10 to the 3 kg, multiplied by g, which is 10, then multiplied by the height in meters, which is 20. If you do it on your calculator, you are gonna get minus 900,000. Now again, I believe they want it in megajoules, so we're gonna divide it by 10 to the power of 6. So answer divided by 10 to the power of 6, you are gonna get minus 0.9. So our answer for part B is minus 0.9 megajoules. Now part C, the work done by gravity as the train moves from position 1 until position 4. Okay, from position 1 until position 4. When we're talking about work, it does not depend on the path it moves. It depends from the initial position and the final position. So again, it's going downward, so we're gonna use plus mgh. Okay, m in this case is 4.5 times 10 to the 3, multiplied by g, which is 10, multiplied by the h, which is 40 meters plus 20 meters, we will get 60. And again, we will get 2,700,000 joules. They want it in megajoules, so we're gonna divide by 10 to the power of 6, and then we will get 2.7 megajoules. So your answer for this one is 2.7 megajoules. Now, question number 2. A block of mass 3 kg descending from the top to the bottom of a rough inclined plane. So first of all, we have the mass. Descending means it's going down from the top to the bottom of a rough inclined plane, meaning there is friction at a constant speed. Constant speed means that the net force is equal to 0. Okay? The angle of elevation of the plane is 30 degrees. If this is 30, then this is 90 and this is 60. Okay? And the length of the plane is 5 meters. Use G is 10 meters per second squared. Now the total work done by normal reaction, anytime you see normal reaction, put 0. Quickly, normal reaction, you see it, 0. Now the total work done by the gravity. The work done by gravity, we said if it goes down, then it is positive. But if it goes up, then it is negative. So it is descending, so it's going down. So it's going to be minus mgh. The work, my bad, it's going to be plus. You see, when you don't focus and you do silly mistakes like me, don't do like me. If it's going down, it is going to be plus mgh. So if we're going to replace, it's going to be 3 times 10 times h. Question, is h the sloped distance or the vertical distance? It is the vertical distance. So to find h, you know that we have a 30, 60, 90 triangle, which is a semi-equilateral triangle. So you should know from last year that this side, which is the 60 and 90 side, is equal to half of the hypotenuse. So this is 2.5 meters. So it's going to be 3 times 10 times 2.5. And if you do it on your calculator, you are going to get 75 joules. So here the answer is 75 joules. Now the total work done by friction. Okay, very, very important. They told us that it is at a constant speed. Constant speed means the net forces are equal to 0. Net force means force 1 plus force 2 plus force 3, etc. is equal to 0. Here we have only 2 given forces, which is the force of weight, okay, plus the force of friction. Instead of using force, we can easily use the work because the distance is it doesn't matter. So you can do that. So you can say then if you see constant speed, that means the net work is equal to 0. Okay, so that means the work of the gravity plus the work of the friction is equal to 0. The work of the gravity is 75, plus the work of the friction is equal to 0. Move it to the other side, then you get that the work of the friction is equal to minus 75. Pay attention, in the exam, do they need the magnitude or the work? Here they need the work, so you will put minus 75. Okay? Question number 3. A box of mass 15 kg is lowered through 2.5 meters. First thing, mass. Second thing, lowered through 2.5 meters. This is the height, and we have g. They need the work done by gravity. Anytime we see gravity, if it goes down, it is plus mgh. If it goes up, it is minus mgh. So here it's going down, so it is plus mgh. Okay, the mass of the box is 15 kg multiplied by g, which is 10, multiplied by the height, which is 2.5. Do it on your calculator. You are gonna get 375 joules. So for this one, the work done by gravity is 375 joules. Question number 4. A small ball of mass 0.20 kg is projected at 10 meters per second. This is velocity initial. Keep it in mind. At a height of 8 meters. This is our height. The only force acting on the ball is the force of gravity. Take g is 10 meters per second squared. They asked us the work done by gravity on the ball. Okay? We know that the work done by gravity is plus or minus mgh. The ball, is it going up or down? It is going down. How do you know it's projected? That means it's falling. Anyway, see the path it is going to. It is falling. So, since it is going down and we're talking about gravity, we will use then plus mgh. Our mass is 0.2 kg, our g is 10, and our h is 8 meters. So if you're gonna do it, 0.2 times 10 times 8, you will get 16. So the work done by gravity is 16 joules. Now, according to the work energy theorem, the work energy theorem states that the change in kinetic energy is equal to work. Kinetic energy, just like a small note, is equal to 1 over 2 times the mass times the velocity squared. Okay? Now, they're asking for what? Let's go down. They're asking for the kinetic energy of the ball as it is about to hit the ground. So we know kinetic energy, the change in it, is equal to the work. We have our work, which is 16 joules. It's equal to the kinetic energy final minus the kinetic energy initial. They are asking for what? The kinetic energy final. We need to find it. Okay? We can very simply find the kinetic energy initial, move it to the side, and then we will find the kinetic energy final. So we know the rule for kinetic energy initial. For kinetic energy initial, yes, is 1 over 2 times the mass, which is 0.2, times the velocity initial. Velocity initial is what? It is 10 meter per second squared. So 10, and then we are going to square it because it is velocity initial squared. So now we have kinetic energy final minus 1 over 2 times 0.2 times 10 squared is equal to 10. So kinetic energy final minus 10 is equal to 16. Move it to the other side, you will get that the kinetic energy final is equal to 16 plus 10, which is then 26. And khalas, you found it. Very easy. 26 joules. Now the speed of the ball as it hits the ground to the nearest integer. We found kinetic energy final, which is what? It is 26 joules. Now they're asking for what? The speed of the ball as it hits the ground, meaning the velocity final. To find kinetic energy final, we know its equation is 1 over 2 times mass times v final squared. Okay, so it is equal to 26 joules. Substitute 1 over 2 times 0.2 kg times v final squared is equal to 26 joules. Move it to the other side, you will get that v final squared is equal to 260 joules. To get rid of the squared, we're going to put radicals on both sides. And so now we have a v final is equal to radical 260, which is approximately 16. So the speed of the ball as it hits the ground is 16 meters per second. Question number 5. A student of mass 40 kg, we have a mass, ascends through 50 stairs, each of height 30 centimeters. Anytime we have height that is not in meters, we have to change it to meters. So 30 centimeters into meters, we are going to divide by 100, and then we will get what? 0.3 meters. Use g as 10 meters per second squared. Pay attention. They are telling us that the zero level of the gravitational potential energy, so they need the gravitational potential energy. They told us the zero level, the reference level, is at the bottom of the stairs. So if the student is ascending, for the gravitational potential energy, it is the complete opposite of the gravity. So we said for gravity, if we go up, it is minus, and if we go down, it is plus. However, for the gravitational potential energy, if we go up, it is plus, and if we go down, it is minus. So here he is ascending, he's going up. So plus mgh. His mass is 40 kg. Multiplied by g, which is 10, multiplied by the height, which is 50 stairs, times 0.3 meters each, so 15. You will get 40 times 10 times 15, you will get then 6,000 joules. But they need it in kilojoules, so from joules to kilojoules, we are going to divide by 1,000, and we will get 6 kilojoules. So the answer over here is 6 kilojoules. Question number 6. A construction worker of mass 90 kg is moving through the floors of an unfinished building. The height of each floor is 4 meters. The reference level for gravitational potential energy is the first floor. So the GPE is equal to 0, as shown in the diagram below. Take G is equal to 10 meter per second square. Okay? Now, the gravitational potential energy of the worker standing on the ground floor. To know if the gravitational potential energy is plus or minus, look what we will do. We will start from the reference level. He is standing where? He is standing in the ground floor, so it's down. The arrow is pointing down. If the arrow points down, then for the gravitational potential energy, it is what? It is minus. So we will be using minus mgh for the first one. His weight is what? 90 kg multiplied by g, which is 10, multiplied by the height of one floor, which is 4 meters. If you do it on your calculator, you will get minus 3,600. And I believe they want it in kilojoules. So to change it from joules to kilojoules, we will divide by 1,000 and we will get minus 3.6 kilojoules. So for the first one, the answer is minus 3.6 kilojoules. Now, the gravitational potential energy of the worker standing on the first floor. We said the first floor is the reference level. If he is on the reference level, then his GPE, his gravitational potential energy, is 0. Part C, the gravitational potential energy of the worker standing on the third floor. As we said, do we use plus mgh or minus mgh? Let's see. We start from the reference level and then we go to where the worker is. The arrow is pointing upwards, so upwards for the GPE means plus, so we will use plus mgh. His weight is 90 kg. His mass is 90 kg. His g is 10 meter per second squared, and the height of each floor, pay attention, he goes 2 floors, so 4 plus 4, it becomes 8 meters. How did we get 8 meters again? This is the first floor, this is the third floor. He is now 2 floors above the reference level. Each floor is 4 meters, so 4 meters plus 4 meters, you get 8 meters. If you do it on the calculator, you will get 7,200. This is in joules. I'm pretty sure they want it in kilojoules. It becomes 7.2 kilojoules. How you divide by 1,000, or 10 to the power of 3. If you're switching from joules to kilojoules, you divide by 10 to the power of 3. Okay? So that's how we got 7.2. Question number 7 is very, very, very important. Which statements are true about the gravitational potential energy? Let me explain about the gravitational potential energy. Every time we're talking about gravitational potential energy, it has a reference level, or the 0 level, and where the GPE is equal to 0. If we go up from the GPE, it will be plus mgh. If we go down from the GPE, it will be minus mgh. Down can mean from the GPE, or it can mean like this. So this is minus mgh because it's going down. Up can mean from the reference level, or it can mean like this. So this is what? Plus mgh. So down means minus, up means plus. Okay? This is the case for GPE. Now it's the total opposite of what, if you remember? It's the total opposite of gravity. We said gravity, if we go down, it is plus mgh, and if we go up, it is minus mgh. So if we were to write a rule between the GPE and gravity, we will say that the GPE is equal to minus gravity, the opposite of the gravity. Okay? One more final thing about the GPE. GPE is equal to m, so plus or minus mgh. So it's directly proportional to the mass, directly proportional to the height, but why not g? Because g is always constant. So if they give you mass, if they give you height, it is correct in the exam. So now that we explained about the GPE, let us answer. The change of GPE equals the negative work done, correct? GPE is always given with respect to a reference level, correct? And the GPE of a body is proportional to its mass. These 3 are correct, whereas the other 2 are incorrect. Question number 8. The mechanical energy, let me have a brief definition. Mechanical energy is what? It's equal to kinetic energy plus potential energy. What is the potential energy we learned about in this chapter? The GPE. So very simply, in this chapter, mechanical energy is kinetic energy plus the gravitational potential energy. Okay, so kinetic energy is 1/2 times mv squared plus GPE, which is plus or minus mdh. How do we use it? When will we use it? We will see in an example like this. Mechanical energy, we know what it is. of an eagle flying at a height. We have the height, which is 3 meters. 3 times its gravitational potential energy. So let's put a rule. They told us the mechanical energy is equal to 3 times its gravitational potential energy. So 3 GPE, sorry. We have the mass of the bird and then G. Very simply, we can find our GPE by doing M times G times H. But is it plus or minus? Look, he is flying. If he is flying, that means he is going upwards. And for GPE, if you go up, it is plus mgh. So let's only substitute. We will have then 4 times 10 times 3. So it is 120 joules. So the GPE is 120 joules. Then they asked us for what? The mechanical energy of the eagle. We built the relation that the not always, only in this question. Please, the mechanical energy is not always equal to 3 GPE, only in this question since it's given, okay? Mechanical energy is equal to 3 times the GPE, which is 120 joules, okay? So it is then 360 joules. So we have the value of our mechanical energy, which is 360. Now the speed of the eagle. We know mechanical energy is equal to kinetic energy plus gravitational potential energy. We have mechanical energy, 360 joules, equal to the kinetic energy that we need to find, plus the gravitational potential energy we have it is 120. Move it to the other side. You will get that 240 is equal to the kinetic energy. What is the rule for kinetic energy? It is 1/2 times mv squared. So then 240 is equal to 1/2 times the mass, which is 4 kg, times the velocity, or the speed squared. The speed is what we need to find. So if we bring this to the other side, you will get that the speed squared is equal to 120. So then if we put a radical on both ends, on both sides, you will then get that V is equal to radical 120, which is 10.9, which is approximately 11. So the speed of the eagle to the nearest integer means whole number, is 11 meter per second, and here this was 360 joules. Question number 9. A puck of mass 200 grams. In physics, we use what? The mass in kilograms. So to change it to kilograms, it becomes 0.2 kilograms. It slides along a smooth curve-shaped track from A to B to C. At point A, the block is at rest. Use G is 10 meter per second squared. They're asking us for the speed of the puck at point B. First of all, we have what? We have mass, which is 0.2 kg. We have G and we have the height. So we have M, we have G, and we have H. We can find what? We can find the work. But they are asking for the speed. Anytime they ask you for the speed and you can find the work, use the work energy theorem, which is that work is equal to the change in kinetic energy, which means that work is equal to kinetic energy final minus kinetic energy initial. To find the work, we are going to do mgh. Work is equal to m times g times h. Here we will not put plus or minus because they didn't tell us gravity, they didn't tell us gravitational potential energy. So if they didn't give us if it's gravity or GPE, we will use it as plain mgh. So what is the m? It's 0.2. What is the g? It is 10. And what is the h? It is 0.8 meters. So the work is then 1.6. Let's now substitute work. 1.6 is equal to kinetic energy final. What is the kinetic energy final? We know that the rule for the change in kinetic energy, to make it simple for you guys, instead of doing 1/2 mv final squared minus 1/2 mv initial squared, you can take in common the 1/2 m, and then you will get this equation, which is really simple. 1.6 is equal to 1/2 times the mass times v final squared minus v initial squared. No need to make it 2 times, do it 1 time. 1/2 times mass times v final squared minus v initial squared. Don't forget the parentheses. So now if we're going to do it, it's going to be 1.6 is equal to 1/2 times the mass, which is 0.2 kg, multiplied by the velocity final squared, which we need to find, minus the velocity initial squared. That's velocity initial. We know at point A the block is at rest, so minus 0 squared. Then if we are going to solve it, you will get 1.6 divided by 0.1 is equal to V final squared. So 16 is equal to V final squared. To find the value of V final, we're going to put radical here and radical here. Then we get that V final is equal to 4. Very simply, we found the speed at point B, which is 4 meters per second. Now the speed of the puck at point C, very, very important. Now, to find the speed of the puck at point C, what are we gonna do? First of all, we have our work, which we found last time. It is 1.6 joules, okay? Now, we need to find the speed. If you have the work and we need to find the speed, you use the work energy theorem, which is that work is equal to the change in kinetic energy. So, work is equal to kinetic energy final minus kinetic energy initial. Our work is 1.6. It is equal to what? You can, as I told you last time, you can make it one simple equation, which is 1 over 2 times m times v final squared minus v initial squared. Okay? Now, we're gonna do it again. 1.6 is equal to 1 over 2 times the mass, which is 0.2 kg. Remember, mass always in kg. Multiplied by the velocity final squared, which we need to find, minus the velocity initial. It's going from B to C. So we found the speed at B, which is 4. So minus 4 squared. Then if you solve it, it is gonna be you are gonna get that 16 is equal to V final squared minus, and then minus squared. So, and minus squared will become plus, so now plus 16. I know it's a bit confusing, but wait, if I will solve it, then you will see why I'm doing this. Plus 16, which is very unusual, but now let's do it like this. 16 is equal to V final squared plus 16. Bring it to the other side, now you will get what? 16 minus 16 is equal to V final squared. 16 minus 16 is 0. 0 is equal to V final squared. So V final of C is 0. The speed of C is 0 meters per second. If you don't want to do this step and get confused, you can see that C is at the same point as A. So since they're at the same point, definitely they will have the same speed, which is 0. Because why? Point A was at rest. So definitely at point C, it will be at rest, 0. Now, assume now that the track is not smooth, meaning there is friction, and the speed of the puck at B is 3 meters per second squared. So now it was 4 meters per second, 3 meters per second now. They're asking us the amount of the initial mechanical energy lost as heat when moving from A to B. Whenever they ask you for mechanical energy lost as heat, what you could do is, it might be confusing, okay, but now they're telling us the track is not smooth. Usually when the track is smooth and that it is it's moving constantly, then you say that mechanical energy final is equal to mechanical energy initial. This is what the law of conservation of mechanical energy. This is only the case if it is a smooth surface and it is a constant speed, okay? So now the mechanical energy lost as heat when moving from A to B. Since it's not smooth, we have a new equation, which is the mechanical energy lost is equal to the mechanical energy final minus the mechanical energy initial. Okay? This you can change it to what? The change in mechanical energy, if you want. Okay? So, mechanical energy moving from A to B. We know the rule for mechanical energy is what? Kinetic energy plus gravitational potential energy. صح? Okay, we are gonna start. The mechanical energy for initially, which is for A. Okay? We're gonna find the kinetic energy initial, which is for A, plus the GPE initial, which is for A. We know that at A, it was at rest. If you go up, let me go up. At point A, it was at rest. So let me write again. We need to find mechanical energy change in mechanical energy is equal to mechanical energy final minus mechanical energy initial. Now we're finding mechanical energy initial. We know that it is kinetic energy initial plus GPE initial. We know that the kinetic energy initial of this was 0. Why? Because the block is at rest. Anytime you see the block is at rest, then the kinetic energy initial is 0. It's not actually 0, but the velocity is 0. And if you put it in the equation, you will get that the kinetic energy initial is 0. Plus GPE, you're going to do mgh. Here they told us they need the GPE. Is it going up or down? To be honest here, I feel there's no need to do the plus or minus. So let's just stick with the mgh. Because it's kind of unclear since it's a smooth curve, even though we have up and down. I prefer for this question, this specific question. Otherwise, do plus or minus, see if it's going up or down. But for this specific question, since it's not clear, we will just stick with the plus GPE. So now, the change in mechanical energy is equal to mechanical energy final minus mechanical energy initial. We know that the kinetic energy is 0 and the GPE, in this case and only in this case, I will give you another way to do this after, but let's use this equation. The change in mechanical energy is equal to mechanical energy final minus mechanical energy initial. Kinetic energy initial is 0, plus the gravitational potential energy initial, which is plus mgh, only in this case, even if it's going down. I will explain another way, which is a more accurate way, okay? But let's use this one for now, okay? So it's gonna be then plus 0.2 times 0.8 times 10. 0.2 is the mass, we changed it to kilograms. 0.8 is the height and 10 is g. So we're gonna get 1.6. So for the mechanical energy initial, we have 1.6. Now for the mechanical energy final, we have also kinetic energy final plus GPE final. Only by looking, you can notice that here this is the reference level. So reference level means that the GPE of the final is 0. Now the kinetic energy final changed to what? The velocity final is no longer 4. If you go back down, I won't go back down because I want to keep this right now. They will tell you that the speed now changed to 3. The speed at B now changed to 3. So the velocity final is 3. Now we will do 1 over 2 times 0.2 times 3 squared plus 0. If you do it on your calculator, you are gonna get 0.9. So the mechanical energy final is 0.9. You can do 0.9 minus 1.6 and then you will get minus 0.7. So over here it is minus 0.7 joules. Now let me explain the second way. You can find that the mechanical energy lost like this. You can do the total mechanical energy is equal to mechanical energy initial plus mechanical energy final. Let's say we're doing it like this. Mechanical energy initial is what? The GPE, okay, plus the kinetic energy initial, plus what? The mechanical energy final, which is GPE final, plus kinetic energy final. Now this one will make more sense in terms of the gravitational potential energy. So for the mechanical energy initial, the GPE is, first of all, it's going down, so it's going to be minus mgh. So then it becomes minus 0.2 times 10 times 0.8. And so then you get what? Minus 1.6. So now you have mechanical energy initial, which is minus 1.6. Use this way, I prefer it because it's more logical, you know? Even though that one is the way it is supposed to be in the book, use this way, okay? Use this way, it's more, it's nicer, it's easier. Now for the mechanical energy final, what are we gonna do? We're gonna, sorry, I forgot to do the kinetic energy. Now the kinetic energy, since it's at rest, it is gonna be 0. So like that, we found the mechanical energy initial. For the mechanical energy final, the GPE is 0 since it is at the reference level. Then the kinetic energy final is 1 over 2 times the mass, which is 0.2, times the velocity squared. What is the velocity currently? It is 3, because if you go down, the speed is 3, so 3 squared. If you do it on your calculator, you will get 0.9. So now it's minus 1.6 plus 0.9. Very logically, way more like simpler and logically. And then we will get the answer, which is minus 0.7. So you can do it this way, correct? You can do it the previous way, but it's more trickier, more riskier. So I prefer you do it this way. The total mechanical energy is equal to mechanical energy initial plus mechanical energy final. So you will get minus 0.7. You can put 0.7 if you want, because they are saying the energy lost, or you can put minus 0.7. I'm gonna put 0.7. Why? Because they told us the mechanical energy lost as heat. If they told us the energy gained, yes, then I would put minus 0.7. You can put both, but I prefer that you put 0.7. Okay? Question number 10. Okay, this one, I don't think we've ever done it before, but I searched up how to do it and I will explain it in a very simple way. Okay? Don't worry. We have a 200 gram bob. We'll change it first of all to kilograms, so 0.2 kilograms. Of length 0.8 meter. This is length, but is it the height? Let's see. It's projected at 2.0 meter per second. This is V initial horizontally. So this is the horizontal distance, meaning it's not the height. Height is vertical distance. Okay? From its lowest point, take G is equal to 10 meter per second squared. They're asking for the cosine of the maximum angle. Anytime you see maximum angle, that means the angle at which all of the kinetic energy is converted into potential energy. That means what? The kinetic energy will be equal to the potential energy. In this chapter, the only potential energy we're learning is the gravitational potential energy. So very simply, at the maximum angle, the kinetic energy is equal to the gravitational potential energy. Now, if we are going to find the kinetic energy, first of all, it is 1 over 2 multiplied by the mass, which is 0.2 kg, multiplied by the V, which is 2, and then we square it. So 1 over 2 times 0.2 times 2 squared is equal to the GPE. GPE is M times G times H. We have M, we have G, but we don't have H. So if we do this, we are going to find what? We are going to find H. Okay? So this is our equation. If we substitute these, we will have here 0.2 times 10 times H. Okay? If you solve the left-hand side of the equation, you are gonna get that it is 0.4. So now over here, 0.4 is equal to 0.2 times 10 times H. Bring these to the other side, you will get 0.4 over 0.2 times 10, and then you will get that H is 0.2 meters. Now, we found what? The height, which is 0.2 meters. Alright, here is where something very important comes. I know we haven't taken this, I don't think it will come in the exam, but it's not wrong to learn it. It's always good to learn new information. So, you will do, first thing that you're gonna do to find the cosine of the maximum angle, anytime you see cosine of maximum angle, what you are gonna do is 1, okay, minus the smaller distance, which is 0.2, over the bigger distance, which is 0.8. So again, anytime you see cosine of the maximum angle, it is 1 minus the smaller distance over the bigger distance, and then it will be equal to what? The cosine of the angle alpha. This means alpha, okay? So if you do 1 minus 0.2 over 0.8, you are gonna get 0.75. So 0.75 is equal to the cosine of your angle, of our angle alpha. This is if they asked us for the cosine. If they asked you for the angle, what you do? You do cosine inverse. So shift, you do shift cosine, then you put 0.75, and you will get approximately 41 degrees. This is the maximum angle that the pendulum can make with the vertical. Okay? Now, question number 11. A ball of mass 1.2 kg is moving vertically above the ground, so it's moving upwards 2 meters. This is the height. At 5 meters per second, so this is what the speed or the velocity. They told us use g is 10 meters per second squared. They told us take the zero level of the GPE on the ground level. What we are gonna do is very simply, they need the total mechanical energy, صح? But the mechanical energy here, it is, sorry, if I speak Arabic sometimes, sorry. Mechanical energy is equal to kinetic energy plus gravitational potential energy. Okay? Now, the kinetic energy, we know its equation is 1 over 2 times the mass times the velocity or the speed squared. Plus the gravitational potential energy, it can be plus or minus gravitational potential energy. So, how do we know if it is plus or minus? If it is going up, يعني, it is plus GPE, plus MGH, sorry. Or plus GPE because it is gravitational potential energy. If it goes up, it is plus. If it goes down, it is minus. Here it is going up. So we're gonna be using 1 over 2. Let me use a different color so it is clear. 1 over 2 times m times v squared plus, in this case it is plus mgh. Now if you substitute the equation with numbers, it will be 1 over 2 times 1.2 times 5 squared, okay, plus 1.2 times 10 times 2. If you do it on the calculator, you are gonna get 39. So our answer is 39, oopsies, 39, sorry, 39 joules. Okay? Question number 12. Okay, so a block of mass 1.6 kg is projected up, goes up a smooth inclined plane at 3 meters per second. This is velocity initial. It comes to rest, so velocity final in this case, it comes to rest. So in the beginning it was 3 meters per second, then it became 0 meters per second at the top of the inclined plane in position 2. They told us take g is 10 meters per second squared and the reference level is the initial position. So here the GPE is equal to 0. What we can deduce from reading, is that from at the bottom our GPE is equal to 0. Why? Because the reference level is at the initial, where the initial block is. Whereas here, since it comes to rest at the top, that means our velocity final is 0. So then we can say that our kinetic energy final is equal to 0. So now, they're telling us, drag and drop the correct answers to complete the sentences below. They asked us, so they are asking us for the initial mechanical energy of the block. Okay? We know mechanical energy is equal to gravitational potential energy plus kinetic energy. Here the kinetic energy is 0. The gravitational potential energy is 0. And then the kinetic energy is 1 over 2 times the mass, 1.6 times the velocity squared. So if we do it on our calculator, we are gonna get 7.2. So the initial mechanical energy of the block is 7.2 joules. So notice here they said it's projected up a smooth. Remember when I said smooth or constant velocity means that mechanical energy initial is equal to mechanical energy final. So the mechanical energy initial, if it was 7.2, it will be equal to the mechanical energy final, which is 7.2. So directly the mechanical energy of the block at the top, which is mechanical energy final, is 7.2. Now the elevation of the inclined plane y, they're asking for the height. Now we said height is equal to the vertical distance, yes? So we have here the mechanical energy is equal to gravitational potential energy plus kinetic energy. We know the kinetic energy is 0 because it is at rest. Plus the gravitational potential energy, which is mgh. It's plus mgh. Why? Because it's going upwards. It's going up a smooth inclined plane. So we have that the mechanical energy, which we got to be 7.2, is equal to mgh plus 0. If we solve it, 7.2 is equal to 1.6 times 10 times h. To find h, we're gonna move 1.6 times 10 to the other side. It becomes 7.2 divided by 1.6 times 10. We get that h is then equal to 0.45. So like that, we found the height of the inclined plane y. Question number 13. A pump is used to lift 200 kg mass of water. Lift, means to go up, okay, of water by the height of 6 meters in 2.5 minutes. Whenever we have time, we change it from minutes into seconds. So we multiply it by 60, it is then 150 seconds. Use G is 10 meters per second squared. First, we need to find the work done by the pump against gravity. Did they tell us the work done by gravity or the work done against gravity? The work done against gravity. The work done against gravity is basically GPE. Anytime you say against gravity or GPE, it's the same thing. So since it's going upwards, it is plus mgh. So our mass is what? 200 kg. And it's plus multiplied by g, which is 10, multiplied by the height, which is 6. So if you do it on the calculator, you will get 12,000. Now this is what? This is the work in joules. So 12,000 joules. They need it in kilojoules. From joules to kilojoules, we are going to divide by 1,000. And so then we will get 12 joules. So we found what? We found 12 kilojoules, So we found the work done by the pump against gravity, which is 12 kilojoules. Now the power. Power is equal to work over time. Remember this equation, okay? Power is equal to our work, which is, the work is always in joules. So it is 12,000 joules divided by the time in seconds, which we got as, I believe, 150 seconds, if I'm not mistaken. So if you do it on your calculator, 12,000 divided by 150, you will get 80 watts. Watts is what? It is the unit of power. So like that, we found the power delivered to the pump, which is 80 watts. Question number 14. A car is moving at a constant speed, meaning net force is equal to 0. If the engine along a horizontal road, if the engine exerts a force of 5 kilonewtons, okay, 5 kilonewtons, which is 5,000 newtons, okay, moving the car through 880 meters, this is our distance, in 80 seconds, this is our time. They need us to find what? The work done by the car engine. So we know work is equal to force times distance. So force times distance, in this case, is 5,000 newtons times 880. Use them in their basic units, the SI units. If you do it on the calculator, you will get 4,400,000, I believe. 4,400,000. Okay, this is what in joules. But نحن, do we need it in joules or in megajoules? We need it in megajoules. So from joules to megajoules, we are going to divide by 10 to the power of 6. So answer divided by 10 to the power of 6, we are going to get 4.4. So the answer over here is 4.4 megajoules. Okay? Now, the power is what? Power is work over time. How much work you can do in a specific amount of seconds. If you can do a lot of work in a short amount of time, you have lots of power. You're really strong then. If you can do small work in a bigger, if you can do the same work but in a bigger amount of time, you will have less power. This is what power means. Now, we got our work, which is 4.4 megajoules, which is 4,400,000. What a big number. Joules divided by the time, which is 80 seconds. If you do it on the calculator, 4,400,000 divided by 80, you will get 55,000. This is in what? In watts. They need it in kilowatts. So to change from watts to kilowatts, we are simply going to divide by 1,000. And so then you will get that it is 55 kilowatts. Now, last but not least, the final question, and it seems that it's easy. So let us solve it together. A column crane lifts upwards 320 kg mass of construction material up 12 floors in 120 seconds. Here, this is 12 floors. The height of each floor is 3.2 meters. So 12 times 3.2 to get the height of the full thing, which is 12 times 3.2. It is 38.4 meters. So now we have our height. Okay? We have the time in seconds, and we have g, which is 10 meters per second squared. So they're asking for the power. We know power is equal to work over time. Work in this case, we have the mass, we have the g, and we have the h. They didn't tell us gravitational potential energy, they didn't tell us gravity, so it's neither plus nor minus. It's just absolute value, mgh. Okay? Imagine there is an absolute value, so it will stay always positive, mgh. Now, over what? The time, which is 120 seconds. If you substitute it, I'll do it over here. It is gonna be 320 times 10 times 38.4 divided by 120 seconds. So let us do it together. Then we are gonna get 1024 watts. So very simply, we got our answer of the power, which is 1024 watts. So let's submit, and inshallah ya Rab, there are no mistakes. Alhamdulillah, nashkar Allah, there are no mistakes. Thank you guys for watching. I hope you enjoyed, and have a wonderful day.